As we all know, the forces that turn the plane are exerted by the control surfaces. This force is proportional to the square of the velocity. This implies that, if you reduce the speed by half, this force and the turning moment are reduced to a quarter. Model airplane pilots are used to the responses of the plane at cruising speed, which is usually around 45 km per hour. When you slow down the plane, you notice that it responds with a certain delay and clumsiness. This is due to the quadratic relationship that we have already pointed out. When some pilots notice that the plane turns little, they tend to move hard the sticks, exaggerating its movements, waiting for the plane to respond to their instructions. These abrupt stick movements destabilize the plane. From an energy point of view, each movement of the plane implies an energy expenditure, which is subtracted from what it already has. If the plane has a certain amount of kinetic and potential energy, when making a turn it loses both. That is, it reduces its speed and its height. This is the reason why you must add some throttle to the plane, that is, to supply it with extra energy, if you are going to make a turn. With this, the plane will not reduce its speed or its height due to the energy expenditure of the turn. If you are landing the plane with a low speed and make it wobble, the plane will lose energy and decrease its speed. This can cause the plane to stall abruptly as it reduces the speed below the stall speed. That said, there are two recommendations when landing a plane. First, align the aircraft with the runway long before starting to descend, so that you do not have to make corrections while executing the landing maneuver. Second, if you have to make any correction in the direction of the plane, it must be done with the rudder and not with the ailerons. Many pilots never use the rudder. This is necessary for two maneuvers. First of all, to perform the coordinated turns. Second, to align the aircraft with the runway during takeoff and landing maneuvers. It is recalled that the rudder rotates the aircraft with respect to its center of gravity, which is a point that belongs to its body. The ailerons, on the other hand, rotate the plane with respect to a center of curvature, which is a point outside its body. Moreover, the ailerons roll the plane, changing considerably the angle of attack of the wings. The rudder yaws the plane, changing very little the angle of attack of the wings. Yawing consumes less energy than rolling. With these recommendations, you will avoid those clumsy landings that we see in the images. And this is all. Thank you.